The current technology is very much doing a great job, but it stops in the segmentation of anatomical features. Actually, if you need to scan through the length of all vessels together in order to find an anomaly in the width profile of these vessels, this is a very laborious process and it's very easy to miss things. And that applies equally to human and to machine. The moment that the data is available, we want to make sure that they can be processed as soon as possible.
What is the end benefit that you try to bring to the table with this technology?
So the end benefit is really targeting the intelligence unit into this loop. So whether it is human intelligence, that is the radiologist, or artificial intelligence, we need to provide as precise description of the condition as one can possibly get. I believe that everything else actually relies on that. So the ability of delivering the right thing is the ability that would reward you with the financial benefit, with everything else. But it all starts from being precise in what you do.
So let's try to understand what specific problem we're solving for MRI and PET scan. Are we solving a problem of these things not being precise enough? And can you give our audience an example of when they're not precise enough or when the project is not precise enough?
I do not think that at this stage the precision is so much the issue with the current technology. The current technology is very much doing a great job, but it stops in the segmentation of anatomical features. So it is having a hard time with the existing algorithmics that is out there to take it a step further and do the automatic detection and diagnosis of various conditions.
Why we need an automatic detection and automatic diagnostics? Like this is the job that the radiologists do today. So what is the problem? Why we need that? Why we need that automation? And
sure, because actually, for example, I will just recall one simple case, and that is, imagine that you're trying to find an stenosis in a blood vessel. So it is very easy to extract the entire vascular network, to extract all the blood vessels in the body or in a specific organ. But actually, if you need to scan through the length of all vessels together in order to find an anomaly in the width profile of these vessels, this is a very laborious process and it's very easy to miss things. And that applies equally to human and to machine. So this is exactly what we're trying to address, and this is where our effort is primarily.
So 1 second, basically this is an effort, if you like, in the prevention space.
It is not only prevention, it is pretty much diagnostics in whatever part of the process this is requested. We might want to be able to address the specific condition prior to anything else. We might be able to address the progression of a specific treatment. So actually the benefits are seen in a number of different directions. Indeed, the improvement in performance, that is accuracy and all the related metrics. So we very much believe that things should be done as fast as possible. Simply, this is the trend, and
So just for be clear, what computation time we're talking about? We're talking about the computation time that the MRI takes to make the MRI.
So this is something that the hardware people would work at the companies building these devices. But the moment that the data is available, we want to make sure that they can be processed as soon as possible. And there is a trend these days that devices get smaller and smaller. And we've seen this in the Radiological Society of North America conference, the RSNA 2019. There were a number of companies presenting mobile CT scanners and MRI scanners that are pretty much the size of a washing machine, which means that in the future we might have ambulances that carry them. And the important thing would be if we can have imaging of the kind being taken at the scene where it's needed immediately. Can we actually process these images in time such that when the ambulance arrives at the hospital, the doctors there know exactly what they are dealing with?
All right. So I think we got this. For our audience, what it is this? Have you seen the movie Star Trek, Star Wars, when the doctor comes in and has this device that can do anything and does and says this guy is dying in 5 minutes? That's basically where we're going. So I know it's a Hollywoodian explanation, but it's more or less where we're going. Like you're moving steps in that direction.
Well, I wouldn't push it to the extent to say that the person is dying or not, but most certainly we do want to prepare as many relevant people in the loop as possible ahead of time. This is why the speed is very important. And at the same time, if you are indeed to consider SATS approaches, for example, mobile scanning units and processing on the fly, then one may want to see this as an edge computing application, so not a cloud computing application, which means that also the cost of the computation needs to be dropped to a very low level, such that you do not need any explicit hardware to run that, but any regular computer should be able to do that. And this brings one more demand into the table, and that is the computational efficiency, the good quality of software.